All right, it's time to take a look at ridge beam B now. Here's the 8-foot building bump out, 20-foot span. Let's take a look at the detail here at C11. There's ridge beam B, which is 1.5 inches thick. You can see the framing point. Ridge beam A is 1.5 inches. You can see how the valley rafters intersect that. And back to the roof framing layout, there's your common rafters at 1A and your valley rafters labeled 3A. This is your rafter layout reference 5J. Here's ridge beam B. There's the height, which is the same as ridge beam A, 5'6" and 5/8. And now we want to take a look at the beam length. All right, we said the span was 20 feet. From that, we need to subtract half the thickness of ridge beam A, so subtract 3/4 of an inch. And there's the 2-foot overhang, so the total beam length is 19 feet, 11 1/4. There's your rafter layout reference at 5J, and that's right at the building line. From that, you do your layout with your rafter square of 2 feet on center. Note that the center line falls in the middle of the rafter layout marks. That's 3/4 of an inch on either side of the center line. All right, again, there's the thickness of the ridge beam A. The beam is notched to accommodate the barge rafter. We're going to make this 7 inches with a 2-foot overhang. Now you can use a 2x10 or you can use a 2x12. I'm using a 2x12. The height is 5'6" and 5/8, as we said, and we're going to enter that into our worksheet. The length we said was 19 feet, 11 1/4 inches. We're going to take a look at the valley rafters now. This is valley rafter 3A, and this is a standard valley rafter. It's the roof framing plan. It's outlined in magenta. There's 2 valley rafters. It's a 20-foot span, so half of that would be the total run of 10 feet. We'll look at the intersect point at C11. It says valley rafter B at the ridge. We'll be using a 4x10 valley rafter in our project. Valley rafters are often doubled or engineered because they have to support a heavy structural load. Ridge beam B, as we said, was 1.5 inches. And there's a 3D view of what the valley rafter will look like in its intersection at ridge beam A. Ridge beam B. There are your valley rafters. And looking at our sample worksheet, we're using 4x10s. There'll be 2 of those. And the total run, as we said, was 10 feet. The unit length was 18. So the mathematical length will be 15, and then 3 feet for the fascia. This is the valley rafter layout. There's the framing point and building line, and the length between those is the mathematical rafter length. There's the math again. Total run of 10 times the unit length of 18th gives us a mathematical length of 15 feet. Between the building line B and fascia line, this will be the overhang length. We said that was 3 feet. Now we're going to look at the seat cut. Seat cut is the bird's mouth. At your height above plate line, which is 7 inches for this project. Your ridge setback. 1/2 the ridge thickness times 1.414. And let's take a look at the detail C2, C9. There's your setback, 1 inch, and there's the formula. 1/2 the ridge thickness times 1.414 gives you a setback of 1 inch. The cheek cut will be 1 3/4 inches, which is half the thickness of the rafter. The thickness of the rafter is 3.5 inches. There's the cheek cut. Next comes the tail cut. The tail cut is double 45 bevel cut, half the rafter thickness. And we've just looked at that detail. This is going to be the same as the cheek cut. This is a 3D view. There's the cheek cut. And there's the tail cut. And here's a drawing to illustrate more in detail what's going on. So it's a 45-degree bevel cut. Rafter thickness is 3.5. Half the rafter thickness would be 1 3/4 inches. Okay, your plancher cut is the same as the fascia height, which is 6 inches. Option A, you leave everything just as it is, and we would be done with our rafter layout. If you want to do option B, this is going to involve a V cut. You have to raise the seat cut, and you also have to drop your plancher line. It's all the same formula, but if you do one, you have to do all three. Now the reason that you would do this, I'll explain in a minute. So let's first take a look at what option A will look like. All right, here's option B. Here's with the V. Now if you decide to do the V, any valley jacks will flush with the top of the V. In other words, you won't have to hold the valley jacks up. So here's the explanation. Option B is the preferred method when rafters are exposed as seen from the bottom. Raising the valley rafter and cutting the V eliminates the gap between the top of the rafter and the bottom of the roof sheathing. So it's kind of rare when you do this, but if you have that situation, do option B. There's the chamfer line, extends the entire length of the rafter. This is a cut through the rafter. All right, this is without the V. This line indicates the bottom of the roof sheathing. You can see the framing point. You can see the height above plate line. So if you do this, make sure you hold the rafter up. In this case, it's 5/8 of an inch. You have to go through the math to determine that. If you opt for option B, you cut out the V. I've got the V indicated in red here. Notice how we raised the valley rafter 5/8 of an inch. The formula we're using is the same as the drop hip method. It's the rise times half the rafter thickness divided by the unit run, which is 16.97. Result is 5/8 of an inch. That's the raised V. To determine your saw cut angle, use that raised V formula. Divide that by half the rafter thickness. Hit inverse, then hit tangent on your calculator. And it'll return a result of 19.50 degrees. So that's your saw cut angle. You set that on your saw, zip along the rafter. As an alternative, you can use the layout method. Go through the steps one by one. You may remember we did this before on the hip rafter tutorial. Or you could use the math method, which we just went through a minute ago, and come up with the same result. All right, you have to do your setback. And this is for the seat cut. So after you do your layout, you transfer those layout lines to the bottom of the rafter and make this cut. This is the plan view of what this should look like from the bottom. There's your building line, there's your setback. So you can see the V. Now if you're going to have a soffit on and you won't see it, you can also do this straight cut. It's much simpler. You just cut back a straight cut through the setback line. There's the math, which you've seen before. There's the detail, which you've seen before. There it is. Here's a 3D view of our project so far. We have ridge beam B set in place now, just kind of hanging out there in the air. You may want to put some supports under that. This is ridge beam B. That's your common rafters, 1A. This is your reference rafter, 5J. Notice it's at the building line. Here are reference lines 5J and 1A. And we're just going to set these rafters in place. Starting with the common rafter. Beginning from the framing point, we'll go out to the building line. We'll mirror that to the other side of the ridge beam. Now we're going to select both of those and do an array. We know that the rafters are laid out at 2 foot on center. We're setting the common rafters first because this helps hold up your ridge beam while you work on your valley rafters. And now we're going to set the valley rafters in place, starting at the framing point at the intersection of ridge beam A and B and continuing out to the inside corner of the building. Here's a good look at the tail cut and the cheek cuts. We're going to mirror that to the other side of the ridge beam and take another 3D view and check out the intersection. So as you can see, if you go for option A and don't V, everything still works out pretty well. For the next video, we're going to look at part 3, and we're going to get into ridge beam C, shortened valley rafters, and supporting valley rafters.